Great. So let me see if it has begun, and then we'll great. Okay. So till last week we discussed things like limits, derivatives, functions, and so on. We discussed how to algebraically solve derivatives and other solve problems related to derivatives. And today we'll be further enhancing our abilities to use derivatives for various uses. So derivatives can be used for various applications. For example, today we'll be using derivatives to understand how a graph, curvature of a graph is, where the graph attains a extrema, and we'll be using some properties with respect to derivatives, for example the Rolle's theorem and Langrange's mean value theorem. So that's the plan for today. So let us begin. We'll also solve questions related to these. Okay, good evening. Let's start. So the first thing we'll be talking about is what is an increasing or a decreasing function. So this is the most simple things to check with derivative. So I say if the derivative is greater than 0, your function is increasing, and if it is less than 0, your function is decreasing. So why is that? First of all, let's see a diagrammatic. So I have the diagram on the left hand side, but again let's for the sake of understanding. So for example, this point, right? So if I draw a tangent or at a point, say x0, so the tangent slope of the tangent is the derivative of at that point, right? Isn't it? We had seen yesterday that the slope of the point was the tangent of the derivative. So what is the slope? Is it positive or negative? Tan theta is greater than 0 or less than 0? It's greater than 0. So okay. So this is because the angle theta is less than 90 degree. So this is why it is greater than 0. So what are we seeing? We are seeing that whenever a curve is increasing, what we have so if say from x some previous value to the new value, the value of the function increase. So the previous value was y1 and this is your y2. So y2 is greater than y1. This means it's increasing, right? So this is the intuition. So if y2 is greater than y1 and x2 is greater than x1, then it's an increasing function. So as your x is increasing, you're having an increase in y as well. So what we do now is we see y is for increasing function. Derivatives are greater than 0. See derivatives, how is a derivative defined? F dash x is defined as limit h tends to 0 f of x plus h minus f of x by h, right? This is how we define derivatives. So my question is if you will agree that, so let's for the time being assume h is greater than 0, right? So we'll not assume the other case. Let's consider the derivative exists. Let derivative exist so that we can only consider the right hand derivative, right? So if the derivative exists, boldly on the right hand side I'm considering the derivative. So what you see is, you will agree that if if x plus h is greater than fx, and you will agree that x plus h is greater than x, right? For all h greater than 0, right? Right, there's no doubt regarding this, right? So if your x plus h is greater than 0, so what does it say? So your x plus h is greater than your previous point x. So for example, so if you have a curve like this is your x and this is your x plus h, right? So if f of x plus h is greater than f of x, so you will have f dash x is greater than 0, as f of x plus h minus f of x is greater than 0. Agreed? Is there any doubt? Why are you all so quiet?
Agreed, sir.
Explain it once again.
No, that's what I'm asking. Where is the doubt?
So this sentence, when you wrote it as f dash x is greater than 0, as x plus h minus f of x is greater than 0.
So what is what is h? H is greater than 0, right?
Yes.
So if the numerator is greater than 0, so you will have a positive number here.
Yes.
If the numerator is as the denominator is always greater than 0, so your numerator, if it is greater than 0, so you will always have a positive number. Agree?
Yes.
So I have told that if your x plus h is greater than f of x, what does that mean? As I have shown that x plus h is greater than x, right? So you're adding something to x to get x plus h, right?
Okay.
No.
Yes.
What is x plus h? X plus h is greater than x, right? H is greater than 0. So you add some number to x, right?
Yes, sir.
So what do I now what I say is, so if the function is increasing, the value of the function at f of x plus h is greater than f of x.
Yes.
Otherwise it is decreasing, right? Or it is constant. If it is,
Yes.
that's what I'm telling. If it is increasing, this implies this.
Yes.
So if this is true, which means that f of x plus h minus f of x is greater than 0. Just taking f of x to the left hand side.
Yes, sir.
Which means the limit is greater than 0, right?
Yes.
Or in other words, the derivative is greater than 0.
Okay. Yes, sir.
So whenever you have a derivative that is greater than 0, you can say that the function in all those points is increasing, right? So that's
Yes.
what I have written. And if it is less than 0, the function is decreasing similarly, because your f of x plus h is less than f of x. Okay. So similarly, there is a definition. Which one should we do? Okay. So I have one question which says that if dy dx for all x is greater than 0, you have to show it is monotonically increasing, right? How can you show that? Monotonically increasing as in this, right? This is monotonically increasing function, for example. Monotonically increasing means f of x2 is greater than f of x1 if x2 is greater than x1, right? This is monotonically increasing function. So if your value of x is, say, f of 5 will be greater than f of 2. Understood? F of 5 will always be greater than f of 2, f of 3 will be greater than 2.9 and so on. Right? So this is called a monotonically increasing function. So you have to show that dy dx, if it is greater than 0 for all x, it's a monotonically increasing function. How will you show that? So dy dx is greater than 0 means what? Limit of x tends to 0 or h tends to 0, f of x plus h minus f of x by h is greater than 0, right? Right? So it's saying that
Yes, sir.
f of x plus h is greater than f of x for all x, right? Agreed?
Yes, sir.
I'm just taking this multiplying h to the to 0 and just taking h on the other side, f of x on the other side. I have taken only the right hand side of the limit. Okay?
Yes, sir.
So f of x
Yes.
plus h is greater than f of x for all x. What does it mean? So if you go to the right by some distance, for any x you will be increasing, right? You're always greater. So which means that f of x is increasing, monotonically increasing. Is this final argument clear? So if for any x, for example, if I write f of x plus h as x2, so x2 plus h will again be greater than f of x2, right?
Yes, sir.
So you can go on writing that way by inductive approach. You can show that for all x, the next number is greater. So if for all x the next number is value of the function of the next number is greater, so you have an arranged sequence, right? So you have an increasing sequence. That's the idea why it is called a monotonically increasing function. So next is we have to show that it's a 1-1 function. So monotonically increasing functions are 1-1, mostly bijective as well. Why? Why are monotonically increasing function 1-1? Can you tell me? 1-1 as in, for if there is x, if what is the definition of 1-1 function? Can you tell me? Not definition, if not definition, just the idea of a 1-1 function.
One element from the set A is paired or is related to only one element in the set B.
Correct. So in set A, or in other words, if f of x1 is equal to f of x2, would imply x1 is equal to x2. That is, in functions multiple elements can link to the same value, right? But in 1-1 function you have only 1:1 mapping. So how can you show that a monotonically increasing function is 1-1? This is because for all x2 greater than x1, right, f of x2 is greater than f of x1, right, by definition of monotonically increasing function. Therefore f of x2 is not equal to f of x1 if x1 not equal to x2, right? Without loss of generality, you can take any two numbers which are not equal. If one of them is greater than the other, the function of that value number is greater than the function of the previous number, right? So your functions can never be equal for two non-equal numbers. Agreed?
Yes, sir.
So if you can show a function is monotonically increasing function, you can say that a function is 1-1. And in many, if it is mapping from R to R or A to A, then you can say your function is 1-1 and onto or surjective and injective function, that is bijective function, right? So you have an inverse. So we have a derivative way to see if a function is. So I had told you before the last day that when we were doing 1-1 functions, that we'll be having a very easy way of checking if a function is 1-1 or not. So if a function is monotonic, it is 1-1, right? That's the idea. So you can just check if a function is monotonic. You can go and say that it's a 1-1 function. Agreed? Let's solve one question, you will understand. So the question is, how many points is sine square x equal to 3x minus 5? So we'll also solve this using the graph calculator, but we'll be first doing it using the graphs. So how can we do it? So I will first show using our old solution way of solving, that is using graphs, right? And then we can go and solve using our the property that we just proved, that if a function is increasing, it's 1-1 or something like that, monotonic. So first, how will I show this using a graph? So how, if two functions are equal, how can you say two functions are equal for a particular value of x? So the question is, your function, the sine square x and 3x minus 5, at how many points are these two equal? This is the question. So any guesses how many points they can be equal? And if you know, if you can guess, can you tell me how did you guess? So this is checking if functions have a point of intersection or not. Yeah. So he's saying intersection. Mr. Pandey, you can speak by unmuting, no problem. No, you're not audible. I think there's some issue with your... Okay, now you're audible.
Left hand side sine square x, graph of sine square x, and right hand side is a straight line.
Yes, but yes. So this is one way to say. So sine square x graph is something like this. Like now the question is, this is your sine square x graph. This is
Yes,
at
sir.
pi. This is 2 pi and so on. 3 pi. Right? We have discussed this many times. Sine x will take a reflection across the x-axis.
Positive.
Yes.
Positive always.
Yes. So this is your sine square x graph. Now my question is, you have 3x minus 5. So you can also have a line like this, right? That cuts many times. If you had a line
Yes, sir.
like this, you had many times it could have cut. But you have to give an idea that how does it cut only once. So I agree it will cut only once. But can you tell me why it cuts only once?
So by graphing.
No, but graphing is not a valid proof. You have to give some argument. So I can draw this line as this way also, no? Then it cuts 3 times.
Yes, sir.
So you have to give me an idea why it is cutting this. So it could have cut more than 1 times if the slope of this graph was more less than 1. Because your sin x graph, sin x is always less than x. Sin x is always less than x. Similarly, sin square x is always less than x. Because it's for smaller values. Right? Sin x is always less than x. We have seen. So if you have, this is the sin x graph, this is your x graph. The graph is always above. It does not cut the graph. So if you increase the slope, 3x would be again greater, right? And minus 5 would be, there will be in the slope, but it will not have enough to sort of cut it twice, because it will be increasing by the time it goes up. If it was 1, it would have cut once. It would have just cut once. If it is more also, you will cut maximum 1 time. You can't cut more than 1 time because your slope is greater. You will already have increased and your sin x graph will be oscillating. Understood? This is the idea. The slope you have to see. But you will gain this idea of, so what did I do? I took the intersection of the left hand function and the right hand function, or I found the roots of g of x. Right? You remember you used to solve equation of 2 lines in your school days by solving the intersection of them. Intersection means where both the equations are holding true. So what I did is I took the intersection of sin square x and this function. These 2 functions I took the intersection. So at this point I have them intersecting. So but this is not a very valid proof. So this is like for any objective question this is good enough, but for properly answering this is not a valid proof. So how do you prove it theoretically? Any idea? Did you understand this first? First understand others?
Sir, I did not got the straight line you made in the graph.
So this is minus 5, right? So you know, how do you draw a straight line? You take an intercept C, -5 is the intercept here, and the slope is equal to tan theta, right? Here slope is 3. So 45 degree would be somewhat like this. This will be x minus 5. So 3x minus 5 will be a larger slope, right? Tan theta is 3. So that's why.
Okay.
That's the idea. So, but how do I solve it using derivative? Just now I showed monotonically increasing function, this thing. So let us consider this g of x. Go ahead.
Sir, IVT and Newton's law.
You don't.
Newton's
No, you don't
method
need.
of finding root.
No, you don't need that. You are just told how many points are there intersecting. So I can prove it very simply. How? See.
IVT.
No. I can prove just by taking the derivative. So derivative is 2 sine x cos x minus 3, right? That is sine 2x minus 3. This is always less than 0, right? The maximum value this can take is 1. Correct?
Yes, sir.
So what does it mean? And you see at x is equal to infinity, g of x is minus infinity, right? Similarly, x is equal to minus infinity, g of x is infinity. Agreed?
Yes, sir.
Now the others, did you understand what I did? I took the derivative and showed that the derivative is always less than 0. So you understood why the derivative is always less than 0? Go ahead. You have a question?
Maximum value of sine 2x is 1. That's why it
Yeah,
should be always.
I understood, you understood, but others did you understand?
No, sir.
What is the problem?
So after the derivative, you told it is less than 0. How it is
So
less
what
than
is the maximum value sine x can take?
1.
So if you subtract 3 from a value, maximum value of 1, how much can you get at max? What is the maximum value of sine 2x minus 3?
Minus 2.
Yeah, so it's and it can be always lesser than that, right?
Yes.
So it's less than 0 always, that's the idea. So subtracting number greater than the maximum value sine 2x can take.
Okay.
So it's always less than 0, right?
Yes, sir.
So if it is always less than 0, it's a monotonically decreasing function.
Yes.
Monotonically decreasing. So you will have, so at minus infinity, if you put minus infinity here, so you will get a positive in minus and minus plus, and sine is always between minus 1 and 1. So you will have g of x is infinity, right? You understood this parts. You need only one side. Say minus infinity is, at minus infinity, g of x is infinity. This is g of x approaches infinity. This you have understood? I think you did not understand. Try to reason yourself. So your graph is something like this. So it's a monotonically decreasing function, so it cannot increase. So there can be at most one value it can cut the x-axis at. So it's a, yeah, you are right in the sense that intermediate value theorem, this is actually intermediate value theorem. After you have shown it's a monotonically decreasing function. So minus 3x you have here. So if you put g of infinity, what do you get? You get sine square infinity minus 3 into, I'm just being a sloppy with my notation. You cannot write infinities in a equation, but I'm just writing to show that there are very large numbers. Let infinity denote a very large number. Instead of infinity, just let's put limit infinity. So what do you have? This is between -1 and 1, right? And this is plus infinity, -5. So what is this value? Any finite number added or subtracted from infinity is? I don't understand what is the problem here. So this is infinity. So you have from infinity you are doing some changing or something. It doesn't change anything as sort. So your graph will look something like this. You will have perturbations according to the sin x function, but you will have a decreasing function. This is the idea. So there's at most one point where g of x is 0. Right?
Yes, sir.
So let's see. Let's try and plot this. So you'll always have a decreasing function. It's a 1-1 function. So let's see. Sine square x minus 3x minus 5. See, I've been a bit sloppy with my drawing there, but did you understand? There is this curves that you are having up and down.
Yes, sir.
But you are more or less having a line, that is, so your derivatives can give you the idea of even how the function will look. So your slope will be around -5 somewhere, so pardon me for that. So it is not slope, intercept will be something around -5. So it's something like this. So anyways, let's go to the next part. So this is how you will use back in increasing and decreasing function, and then you can say by IVT or something like that. So since it's a monotonically decreasing function, you can cut the x-axis at most once, right? It cannot go back. Otherwise it would have been some place increasing and some place decreasing. Understood? Now I go to maxima and critical points. What are critical points? So look at this graph that I've drawn here. So this, you will agree, is the minimum value, right? This at the end here, this is the maximum value that the function can take, right? These two are called the, sorry, this is not the maximum value. What am I drawing? So this is the maximum value that the function can take, right? From the diagram between A and B.
Yes, sir.
So we can see that the value of this, there is a global maxima and a global minima, right? So in this graph, f of A or minus A is global minima, right?
Yes, sir.
And f of, say this point we call it as C. C is your global maxima. Simply from the diagram you can say that is the maximum value that the function can take, right? There's nothing to mention. The word says everything about it. There's no definition that is required, right? So the maximum value of function can take is the global maxima. Minimum value the function can take is the global minima. Now there are also some local minimas and maximas of the function. For example, this is a local minima, this is a local maxima, this is a local minima, and this is also a local maxima. How do you define a local extrema? Local extrema. So if, say, x is a local extrema, comma, then f of x is greater than f, should I write x? No, so let us write some point C. Then f of C is greater than f of x for all x belonging to C minus delta to C plus delta, or in the leaving out C, right? So you have a point like this. You'll agree if you go slightly to the left of this, I'll just write maxima here. Slightly to the left of it and slightly to the right of it, these values are lesser, right? XL and X right. Both XL comma X right are less than f of x, right? Agreed? Why are you people so silent? So is there any, so if you go to the left, the function is going downwards, right? If you go to the right, the function is going downwards.
Yes.
So you can say that this, at this point, the function is the greatest value. Next, what we say is, similarly you can define a local minima at the point in the surrounding all values are greater than that number, right? So we have drawn both here. So I claim that at these points of extremas, your derivative is 0. Can you tell me why? You just now said yes. You have to. Can you tell me why it will be 0? Just the geometric understanding will do.
Horizontal tangent.
Yes. So you see the tangent here at this point where you are having an extrema, you are having this parallel to the x-axis, right?
Yes.
So what is the slope of a line parallel to the x-axis? Tan theta is
0.
0. So at this point, C tan theta is equal to f of x is equal to 0. There is another way to look at this. We told, and these functions are told to have a derivative at C. There may not be all functions. Last day we saw jumping derivatives were not having derivatives. So you see this derivative of this function is decreasing, right? Finally it goes to 0 and then again starts increasing. So it has to be 0, right? From the diagram itself, these were negative values of the derivative. Suddenly it became positive values, and in between 0 must come, right? Similarly you see here, these are all positive values, and then it became negative values of the derivative, right? So it must, in between 0 must come. That's the idea. If your derivative is continuous, differentiable at all points, your derivative has to, by intermediate value theorem, pass 0. Like this, right? This is your derivative function, f dash, something like this. So there is a formal way to show that this function is going to be a local, or your derivative at this function is going to be 0. Tell me, how will I show it? Did you understand the geometric proof? So your tangents became very flat, became 0, and then changed its direction, right? So it's like a ball that is thrown upwards. It stops and then starts to come down, right? So you are continuously decreasing the velocity till it goes to the top point, and then you come down by increasing the velocity. It's exactly the same interpretation here. Anyways, let's do the proof. So let us assume that the derivative exists. So what will be the left hand derivative? Go ahead, define it. So I think you all are not revising stuff that we're doing. Okay, so right hand derivative is limit h tends to 0 plus f of x plus h minus f of x. Right, just the definition would give you the answer. So let us say by continuity, this is a 0 by 0 form. F of x plus h, we took f of x plus h minus f of x is equal to the absolute value as f of x minus h. So the difference in magnitude, we took them to be same, right? Anyways, in some way we took it. Otherwise we can change h always to match the other, right? We can always have an h that such that these two becomes equal. So anyways, so now you tell me this left hand derivative, right? What is it? Which sign should it have? Greater than 0 or less than 0? Tanushri will tell me if you have understood this function. So I am choosing, let's say, this function where it is increasing. Go ahead.
On the left side it will be positive only, but it is decreasing.
So on the left hand side, f of x is greater than f of x minus h, right? I am considering for increasing function. So for maxima, say, I am considering for maximum, right? So I am considering for maxima on the left hand side. You will agree f of x is greater than f of the neighborhood of x, right?
Yes.
So f of this is greater, so this is greater than 0.
Yes.
It can be greater than equal to 0 also. Similarly, f of x plus h is also less than f of x, because this is the maxima. So this is your less than 0. So if this has to be equal, what should it be?
Equal to 0.
Correct. So on either side the derivatives are either positive or negative. So if the derivative must exist, it must be 0. Understood? This is the theoretical proof. I hope now we can go ahead and do some other problems. So but let's see, there's a but here that I wrote down. So my proposition is, so if a local minima or maxima is differentiable, then the function derivative is 0 at that point, right? This is, we have seen now. This is, up to this we are on the same page. But is the converse true? My question is, if a value of a function, if a derivative at a function is 0, is that always a critical point? Is that critical point? Yes. But is that always a local maxima or a minima? This is defined as a critical point. Anywhere the function derivative is 0, if f dash x is 0, I had told previously in assignment week 1 or 2, we'll see this. These are called critical points, but not necessarily, they are not extremas, right? So why is it true? So you see, we said that if a function is differentiable and we have a point C which is a maxima or a minima, the derivative will be 0 at that point, right? We are on the same page up to this. Next, my question is, if at a point the derivative of a function is 0, is the function always going to be, is that point always going to be an extrema? I mean minima or a maxima? Any idea? If derivative is 0, is the function going to be always extrema at that point? Derivative going to be an extrema at that point. No one is answering, so let me answer. So for example, x to the power 5, right? What is f dash x? 5?
5 raised to 5.
So you consider f dash 0. What is it?
0.
So is 0 a critical point for x to the power 5? Let's see. Critical point, yes, always. Is it an extrema for x to the power 5? You tell me. Is f of 0 greater than f of minus h, comma f of plus h? F of x is equal to x to the power 5. Is it true? What is f of minus h? F of 0 is 0. F of minus h is? Answer. This is very simple, right?
minus h power 5.
Minus h to the power 5. And plus h is plus h to the power 5.
Hmm.
So is this true? Now Tanush,
No.
tell me if it is true or not.
No, sir.
Why is it not true?
Because minus h raised to 5 is less than
0. Correct. So f of 0 is not extrema, right?
Yes.
And this is greater than 0. So 0 is between minus h to the power 5 and h to the power 5. So we have seen previously, I did not want to introduce this graph first. Let's do it algebraically. Then I will introduce that any odd power was like this, right? We had drawn x cube and so on. We had told any odd power would be like this, right? Now you see, so Tanushri, I remember you asked me what is the definition of a tangent, and I told you a tangent is always above or below the curve. It necessarily need not be above or below the curve. You see on the left hand side, you consider this as two parts.
Okay.
This is above the curve, you will agree, just the left hand side.
Yes.
Similarly, on the right hand side, this is also below the curve.
Yes.
So only a side of the tangent can be considered, either left hand side or right hand side. They can be your above or below the curve, but not the entire tangent. But you see the entire tangent, it crosses the curve, right?
Yes.
So it sometimes can cross the curve. When it crosses the curve, that is also a critical point. But this is not your extrema point, right? So if you see at a point if a value is 0, the function need not always be your extrema. We need to check multiple other parameters. So we need to go for higher order derivatives. We'll see how to do that next. Understood? So this is not an extrema. So we have understood this part. So next is
What you just said.
huh?
So can you repeat once again what
I
you just
said that
The
if
voice
your
was not audible.
okay, I said if the derivative is 0 at a point, right? That point need not always be an extrema. But if it is an extrema, derivative will be 0.
Yes, sir.
But it will always be a critical point. Those
Yes.
points are potentially points for being an extrema. You can check all the values of that point and see which is the maximum value. That you can do. Right? So let us define what are critical points. Critical points are critical points. So I had talked about it before. So end points of a graph. End points of a function. Right? For function between r to r, what would be the critical point? Minus infinity, infinity, and set of all those x such that xi dy dx is xi is 0. This is defined as your critical point. So let's write generalizing this left comma right as left comma right. Understood? So let's see. So these are called the critical points. Next, what we do is we see which of these critical points are maxima, minima, or neither of these. So you see, if it is now we'll just see that we don't need to do the math here. We already seen this, so we can see very clearly what happens to the slope of the tangent for a downward facing curve. So you see theta 1, theta 2, theta 1 is less than theta 2, right? Greater than theta 2. Sorry. So I was saying that if you have a downward facing curve, so this is your first tangent, this is your later tangent. So what can you say? Your first tangent had a higher angle of inclination than the second tangent, right? Agreed? theta 1 is greater than theta 2, you move
Yes.
further away, your inclination would decrease. What does it mean? That your gradient, so theta 1 and theta 2 are measured for derivative function, right? So tan theta is nothing but the derivative, right? This one we have seen. So what is happening to the derivative? Is it increasing or decreasing? Are the derivatives increasing or decreasing? If theta 1 greater than theta 2, is tan theta 1 greater than tan theta 2? Right? Tan theta is an increasing function. This is your tan theta function. So you see the slope of this tangents are decreasing, right? So when the slope of tangent is decreasing, it means the derivatives are decreasing, right?
Yes.
So if your derivatives are decreasing, your derivative of derivative will be, derivatives are decreasing. Derivative dy dx is decreasing function. So d dx of dy dx, what will it be? Greater or lesser than 0? We are using the derivative.
Less than 0.
Correct. Because your derivatives are decreasing, derivative is also a function, right? So if a function decreases, we have seen the derivative of that function is less than 0. Right? So your d2y dx2 has to be less than 0. So if your function second derivative at a point is less than 0, that is a maxima. If it is greater than 0, then it's a minima. If it is equal to 0, it's called a point of inflection or a point where you have a horizontal tangent, like x to the power 5. You can take the second derivative, you will still have x to the power 3. Again put a 0, you will again have 0, right? Point of inflection or horizontal tangent. So even point of inflection is a horizontal, like horizontal tangent is also a point of inflection, because your what is the point of inflection is next. What will I see? What I will tell you. Your point of inflection is the point at which I have written it down here, where your curve changes curvature, right? Curve changes curvature. This is a very, very interesting thing to understand. So greater than 0, less than 0 is understood, right? So we have no confusion regarding that. For downward function or a maxima is existing, you will have your derivatives decreasing. Similarly, for upward facing functions, your derivative will increase. Now point of inflection is the point at which your curve changes. So if you had a curve like this, can you tell me which side is upward, which side is concave upward, which side is concave downwards, and so on? So I have a point here. So if I cut it L and right, so which side is concave downwards? This is concave downwards, right?
R side, concave downwards.
What does concave mean? You remember, right? This is a concave mirror, where the outer surface is the surface of knot of interest is bulging. That's the idea of a concave surface. So where you are actually seeing, that is inward, right? So you are seeing inside, so you are going in. That was the inward surface, and this is a concave upwards, right? So concave downwards. So you tell me concave downward function will have d2y dx2 as less than 0, and concave upward function will have d2y dx2 as greater than 0. Agreed? We agreed on these two. This is a concave upward function, this is a concave downward side. So in between, what will happen? Somewhere here your derivative function will become a constant function, or your derivative function will reach an extrema. So you see around this point the derivative is all positive, right? dy dx is increasing, right? And this,
Yes, sir.
and this side dy dx is decreasing. Agreed?
Yes.
So if your dy dx is increasing here, say this point is C, below C, and dy dx is increasing here, say somewhere decreasing here, somewhere increasing here, so at C it will be 0. Agreed?
Yes.
Oh no, I think I made a mistake. So it's not positive or negative. This is for the d2y dx2 curve. So it is increasing, right? So on the left hand side it's increasing, something like this. On the right hand side it is decreasing. This is the dy dx function, right? This side, on the left hand side, your gradients were increasing, right? So your gradients are increasing. Agreed? On the left hand side, on this side, your gradients were decreasing. Agreed?
Yes.
So you try to always draw the curve, and so in the between you will have an extrema for that, right? In this case it's a maxima of the derivative. So you will have ddx of dy dx will be 0, right, at this point. That is known as a point of inflection, where the curve is becoming from concave upwards to concave downwards, or vice versa. If it was the other way around, your function, your derivative function would be upward facing, right? Anytime you have a change in complex, like I'll give you an example, you will only answer how many points of conflections are here for this curve. Tell. How many points of inflection are there in this curve? Just by seeing.
3 points.
Let's see. So up to this there is no point of inflection. This is one point of inflection. This is one point of inflection. So there are 2 points of inflection. You thought that this was something like this, right? Maybe yes, I can give you the benefit of the doubt. But these two are the ones I was talking about. Right? Wherever your curve, this was concave downwards, right? And it became concave upwards. Wherever you see a concave downward to concave upward shift, you will have a point of inflection, or your derivative of your derivative will become 0. Right? Curvature, when curvature changes, your derivative of derivative will become 0. So these things you must keep in mind. This will help you to understand, plot graphs yourself. You will understand where to put inflections, where to put maxima, minima, and so on. So now let's go to problem solving. So my question is, can we always blindly take derivatives and say a point is a minima or a maxima? My question is, x square 2 sine x, sine 2x is the definition of this function. So I ask you, at x is equal to 0, is it a local minima or a local maxima? Is it a local extrema? Minima, maxima, forget. So how do you will see if a point is minima, extrema at a point? By taking derivatives, right? I hope you understand. So you have 2x here, and you have 2 cos x here. So I told you how to see if a derivative exists by seeing we had proved if we see the continuity of the derivative will exist or not exist, right? If the derivative is continuous, your derivative will exist. We had shown this. So is this continuous? So at 0, left hand derivative is
0.
Now right hand derivative, Anushri will tell me. What is the right hand derivative?
1.
1. Cos 0 is? What is cos 0? Cos 0 is 1. So 2 into 1 is 2. So you have your derivative function f dash x. How will it look? For x less than 0, for x less than 0 it is 2x, right? Something like this. And for x greater than 0, it's cos x. So you see, is the derivative function continuous?
No, sir.
So if the derivative is not continuous, which means we can't use derivative test to find extrema at points of non-differentiability, right? Only at points where it is differentiable you can use the derivative test to see if it is an extrema. I want to give you an entire picture. I don't want to give you an illusion. That's why I'm giving all these examples. So if you feel it's difficult, you tell me, we'll just solve problems. Then I think more people will come to the class. It takes more effort also on my side. See, so x square, what you have here is, for less than 0, how does the graph look? Something like this, right? And then 2 sin x is like this. Agreed?
Yes.
Yes, sir.
So is this point is it a local extrema?
No, sir.
What do you think, Tanushri?
So is this a critical point?
Critical point, I don't know. Critical point it is not, because the derivatives are not 0. Because it's left and right are, we saw it's not continuous. So derivative is not defined at 0. So I was asking, is it a extrema point or not? Extrema as in, is it a local extrema, local minima, local maxima? Just look at this point and tell me. It's very simple, right?
So maybe it is a local minima.
Correct. It's a local minima. Yet, if it is a local minima, yet dy dx is not equal to 0 because not exist. Because it does not exist. So for mod x also, similarly, wherever you have this sharp boundaries, you will not have derivatives defined, but yet these will be points of extrema, right? This will be, this is the minima. For you can draw many maxima, so derivatives need not be always defined. So you may have to fall back to plotting the curve or seeing the neighborhood at a point. That's the, like, in more complicated functions you cannot plot the curve, so you have to see the neighborhood. If in the neighborhood the function is less, so you can say, you have to use the basic definition. You cannot use the derivative test. What is the basic definition, Tanushri?
So whose definition?
Maximal, say local maximas, definition, like formal definition of local maxima.
Local maxima is a point where f of c is greater than fx for all x belonging to its neighborhood.
Correct.
C minus delta
Correct,
c.
understand. Good. So if you are not able to see the derivative test, you may have to see the proper definition. In the neighborhood, you see the function at this point is the least. That's why it's a local minima. Let's go to problems. Some problems regarding very simple problems. It is given. So I'll give you 1 minute to solve this question. It just takes 1 minute to solve. You will give me the answer, each of you, both of you. So it's given that x is equal to 1. The function f of x is x to the power 4 minus 62x square plus ax plus 9. It attains a maxima in between 0 to 2. What is the value of a? So at 1 it is said it attains a maxima at 1. So what is the value of a such that it attains a maxima at 1? Done? What is the step you will do? The function attains a maxima at x is equal to 1. Very trivial, very like typical questions you can be asked. So you will just take derivative at 1 and put it to 0, right? This is a polynomial function. So in a case of a polynomial function, you can just set the derivative to 0 because it is continuous, it's differentiable everywhere. So you will have f dash x is 4x cube minus 124x plus a is equal to 0 at x is equal to 1. So you will have 4 minus 120 plus a is equal to 0. What is a? A is equal to 120, right? Correct. So a is equal to 120 because you just set the derivative to 0 because f is differentiable. Now just to check if it is a maxima point, you can take the second derivative. It's not required here because you just have one value. So d2y dx2 is equal to 12x square minus 124, which is clearly less than 0 at x is equal to 1. So it's a maxima, right? So I took the derivative again and showed that the second derivative is less than 0, which is actually 112 minus 112. So it's a negative slope. Similarly, let's do question 4. Show that all rectangles of a given area, you have square with the smallest perimeter. So do you have an idea how should we go about doing this? So let's solve this type of questions. It's very common. So what we do is, what is told, area is constant, right? So what is an area of a rectangle? Length into breadth, right?
Yes, sir.
Length into breadth. What is perimeter? 2 into L plus B, right? So you are told to maximize perimeter, right? Or minimize perimeter. Say, where will it be useful? What is an application of this? So suppose you are trying to make a field of a particular area where you want to grow many flowers. So for the growing the flowers, the area is important, right? And not the perimeter, but you want to give fencing to the area. So what you will like to do? You will give the minimum fencing, right? Minimum cost to the fencing, right?
Yes, sir.
So in that case, you will be choosing a square field. Why will you choose a square field? So the idea here is to optimize. This is an optimization problem. Optimize problem. Optimize for what is the variable you are optimizing for? P, right? Perimeter. So we are optimizing for the perimeter. So let's see. So what should I do? So perimeter has to be a function of some dependent variable, but it is now presently a function of two variables, right? I have to make it a function of one variable. I don't know how to solve with two variables. So how can I make it a function of one variable? P as a function of one variable, say length variable, what will it be?
B is equal to A by L.
So I will be using L plus A by L, right? Understood? So I can write B as A by L, right? A is a constant. I want to say I have a 5-acre land. I want to buy a 5-acre land. What type of an area of a 5-acre land do I want to buy? So A is a constant. So now what will I do? Put dp dl to 0. So dp dl is 2 into 1 minus A by L square is equal to 0, or A is equal to L square, which means L is equal to breadth. I went a bit fast in the last few lines, but like especially between these two, but these are like algebraic steps. Did you not understand these two steps? Derivative you understood, right? So derivative of L with respect to L is 1 by L is minus L square, minus 1 by L square, right? L to the power minus 1, this is L to the power minus 1, right? ddl of L to the power minus 1 minus L square minus L to the power minus 2, and then I just set it to 0. So I set it to 0, it becomes A by L square is equal to A by L square is equal to 1. So I cross multiply L and get A is equal to L square. So A is equal to L square is a formula of a square, right? Where L is equal to breadth. So this is the proof. So this type of things can be given for multiple areas. For example, you can use a say cylinder surface area you want to maximize with the same volume. Similarly, you can do so, but we are not yet done. So we have to say if we are actually maximizing it or minimizing it, right? So second derivative is equal to minus 2 into minus 2. So it's 4A by L cube, which is greater than 0, right? L is greater than 0, area is greater than 0. So P is attaining a minima, right? Agreed? So when second derivative is greater than 0, you have minima point. Now let us go to some applications of derivatives. Some theorems. These are very popular theorems known as the Rolle's theorem and the Langrange mean value theorem. What does it say? So visually it's very easy to understand. So if you have two differentiable function, right? There should always be a C such that the derivative at that point, say okay, I'll give you this entire thing together. So say A to R be a continuous function, right? Stay with me, right? So A is a continuous differentiable function. F is continuous and differentiable. Differentiable. Continuous and differentiable function. So which is continuous between A and B, right? So including points A and B. It is said it is differentiable in all points between A and B except A and B. It is not required to be differentiable at A and B. And f of A is equal to f of B, right? Then there exists a C such that C is between A and B such that f dash C is 0. In other words, there must be at least one extrema in A comma B if FA equal to FB. Agreed? It is clear from this curve, right?
Yes.
So if you have 2 points equal to the same value, so let us take both two cases here. So if A and B are both the maximum value or the minimum value, so and they are both the maximum and minimum value, which means the curve does not go anywhere, right? So it's a constant curve, right? If A and B are both maximum or minimum, it means that in between the point does not increase or decrease. If it is increasing, on other points will become maximum and A and B will become minimum. If it is decreasing, A and B will become maximum and other points will become minimum, right?
Yes, sir.
So if A and B are maximum and minimum or the extrema points, which means the function is constant, fc is equal to fx is equal to some k. What is f dash x then? 0, right? Constant ka derivative is 0.
Yes, sir.
Because it's a straight, it's a horizontal tangent and so on for all values. Similarly, if it is not, then by extreme value theorem, or what will you say? There will at least be one point where the curve will attain the maximum. Say if it is not attaining maximum at a comma b, it will attain somewhere in between, right? In some point in between, if the function is continuous and differentiable, it will be maximum, right?
Yes, sir.
So at that point your derivative has to be 0, right?
Yes.
At least one point the function will be extreme. Function will be at the extrema. Since we are assuming differentiable and continuous, so at going to infinity is not allowed. Functions like these are not allowed. If this was there, do you see, does this hold the Rolle's theorem? This function does not hold the Rolle's theorem. Why? Why does it not hold the Rolle's theorem? Because it is not differentiable at this point where it is an extrema. So it has to be differentiable at all points between A and B. Then if it is differentiable at all points, at an extrema point, you will always get derivative equal to 0, right?
Yes, sir.
So let's do a problem on Rolle's theorem. This is the problem. So let's verify Rolle's theorem. I would ask you all to verify the same. Verify Rolle's theorem for f of x between, say, between minus half and 2, root 2. Right? This is the range that is given, a to b. So what is the first thing that you need to verify? Function is continuous. You agree it is continuous function? Polynomial function. Functions are continuous, right? There's nothing to say for polynomial functions. They are always called continuous, right? Because all of these x cube, x to the power 4 and all of these are real number values. So there is no cases of discontinuity. Similarly, B, polynomial functions are differentiable. Agreed? These two properties we all very well know.
Yes.
So for polynomial functions, derivative of a polynomial is always a polynomial function, right? When you have a polynomial function, derivative of that is a polynomial function, which is in turn continuous, because derivative is polynomial. Ddx is polynomial, right?
Yes.
Okay, number C. Let's put f of minus half. What is f of minus half? 2 minus 1 by 8 plus 1 by 4 minus 2 plus 2 minus 2, 0, right? Put minus half is multiplied by 3 times minus 1 by 8 plus 1 by 4, so you will have 0, 2 minus 2, 0. Similarly, root 2 if I put, what will you have? 2 into 2 root 2 minus 2 minus 4 root 2 minus 2. Or yeah, so this is plus. In between I missed. This is also 0. Agreed? So f of minus half is equal to f of root 2 is equal to 0. Right? So the extreme points at minus half and root 2, this function is 0. So all we need to show is, it should actually be, I think, an increasing function, because x cube is positive. It should be facing upwards, whatever it is. So what can you say? What do we need to do now? We have to show that there exists a c between minus half and 2 such that the derivative is 0, right? Then the Rolle's theorem is verified.
Yes.
So what is the derivative of f? F dash x is
6x square.
plus 2x minus 4, right?
Yes, sir.
Is equal to 0. This is what you need to set, f dash x equal to 0. You need to solve for this to get a c. So put c. So you'll get c square c minus 4, right? Right?
Yes, sir. Yes, sir.
3c square plus c minus 2 is equal to 0. So you will have 3c square plus 3c minus 2c minus 2 is equal to 0, or 3c c plus 1 c plus 2 is equal to 0, or c is equal to minus 1 comma minus 2 by or 2 by 3. So 2 by 3 is between root 2 and minus 1 by 2. 2 by 3 is between minus half and root 2, right? This is not there, so we can cancel. Agreed? Root 2 is 1.414. 2 by 3 is 0.67.
Yes.
So is your Rolle's theorem valid?
Yes, sir.
So 2 by 3. So your function is something like this. And at minus 1 also you must have something like this, because the derivative is 0, right? This is your function. Let's plot it and see if you are right. So 2x cube minus plus 4x plus x square minus 4x minus 2 plus x square minus 4x minus 2. Agreed?
Yes, sir.
So using this derivatives and all, we have been able to plot each and every curve also. The derivatives are giving me critical points, the end points are giving me where it is 0, and so on. Isn't this great? So you don't need even a calculator to plot stuff. Only the derivatives can give me all the idea. Okay, this is done. The last concept for today is the Langrange mean value theorem. So what is Langrange mean value theorem? It says that it is nothing but a generalization of the Rolle's theorem. Okay, so if you have a and b, even if they're not equal, there will exist a point C such that the derivative at that point is parallel. The tangent at that point is parallel to the line joining A and B. Okay? Did you understand what I said? So A and B is here, right? If I join these two lines, I will have an intermediate C such that at that C the derivative is dy dx at C is equal to f of b minus f of a by b minus a, right? This is my idea. So this is the slope, right, of the line joining A and B. So if you want to find slope of a line between 2 points, it's f of y2 minus f of y1 by y2 by x2 minus x1. F of x2 minus f of x1 by x2 minus x1, right?
Yes, sir.
So there will always be a line. So this is very similar to the Rolle's theorem. If A is equal to B, right? So if A is equal to B, right, A and B are equal, so that C will be parallel, right? So if A and B are equal, the M is 0, so dy dx at C is also 0, right?
Yes.
So it's a generalization of the Rolle's theorem. How will you prove it? This is actually called a wake up one fine morning and see this is called a constructive proof, and you get a construction that proves it. Now if I write g of x like this, what is g of A? 0, right?
Yes.
F of A minus f of A, and here A minus A. A minus A, right? F of A is 0. F of B is also 0, right? This becomes f of B minus f of A, and this becomes denominator numerator will cut. You again subtract B minus f of B minus f of A, right?
Yes.
Good. Now what is it satisfying? The Rolle's theorem, right? F of A equal to f of B. So G satisfies the Rolle's theorem, right? Since f is continuous and differentiable, so any sum and product of any sum of differentiable functions is always continuous, right? And differentiable similarly. So if this will satisfy the Rolle's theorem, this means there exists a C such that g of g dash C is equal to 0, right? What is g dash C? It is nothing but f dash C. This will get cancelled. This will get cancelled. Minus f of B minus f of A by B minus A is equal to 0. Agreed?
Yes, sir.
So this is your f of B minus f of A by B minus A. This is the proof of the Rolle's theorem, or the Lagrange's mean value theorem. So use the Rolle's theorem to prove the mean value theorem, which is more general, right? So you remember the geometric construction always, that there exists a C such that the tangent is parallel to the slope of the line joining A and B, right? This is what you need to remember. Now let's see question number 5. It's a very simple question. This is in your assignment, so you people ask me to do the tough questions in your assignment, so I'm doing most of the questions today. So minus 2, your derivative is between minus 2 and 2. So what is the maximum increase the function can have from f of 0 in the interval 0 to 6? So what theorem can you use? Any idea?
Mean value theorem.
Lagrange's mean value theorem. Do you agree, Tanushri? How will I use? There are two ways I can do this. I can solve it using an integral also, but integrals we are not considering now. So we'll solve it using a Lagrange's mean value theorem, right? So we know f dash C is equal to f of 6 minus f of 0 by 6 minus 0, right?
Yes.
For C between 0 and 6, right? Next, what steps should I do? Just put, right? So f dash C should be between minus 2 and 2, right? Agreed? By definition.
Yes.
Your derivatives are between minus 2 and 2. Now you put f of 6 minus f of 0 by 6 is between minus 2 and 2, right? Or f of 6 minus f of 0 is between 12 and minus 12. So what is the maximum increase f of 6 can have from f of 0? 12, right? Or just less than 12. Agreed? 12 minus is the actual answer, should be the answer, right?
Yes, sir.
This is one solution. Let's do one more question. Number 6. This is a very simple question. This one I won't do, you will do. I am waiting for yours. I'll give you a couple of minutes to solve this and tell me. This is also your assignment problem. And if you have solved it, you wait. When I'll ask, both of you have been able to solve it, I will ask. So it's told that, say, f of x and g of x are continuous and differentiable such that f dash x is g of x and g or g dash x is minus f of x. It says which of these following option, then we define h of x this way, which is correct, which of the following is true. This is what my question is, which of the following is true. Once you're done, just tell me, I'm done. Don't answer, just say if you're done. You couldn't solve this. Dhanushri, could you solve?
Yes, sir. I did not understand this.
You did not understand or could not solve?
So, means I did not understand h of 0, where I'll put it and what I'll get, what should I do? Just I was confused from the starting.
So what did you think you should do, both of you? Ideally, you should take derivatives and see. So this has said that 0 and 10, right? So it's some way resembles a mean value theorem, right? Between two values. Try to take derivatives and see if you can answer something. Because there are two ranges between 0 and 10, right? So let's see. So if I take the derivative, if it's calculus, right? You have to try derivatives, integration and so on and see which one works. So it's 2 times g of x into g dash x, agreed? Plus 2 times f of x into f dash x, agreed?
Yes, sir.
Just put the value. See, another hint is the derivatives are given, right?
Yes.
Why are the derivatives given? Why do you think the derivatives are given? For you to use, right?
Yes.
In any question, there should be a reason why a particular thing is given. 99.99% of the times, right?
Yes, sir.
So how will you use the derivatives? So if you want to use the derivatives, you need to take the derivative, right? The derivative is not given for h of x. So I took the derivative. Now I'll just put the value of h prime of x, right? 2 into
Yes.
gx into f dash x, right? Or no, minus gx, right? Minus f. This is minus fx.
Yes.
Plus 2 into fx into g of x. So this is 0. Right?
Yes, sir.
It is 0, right?
Yes, sir.
So if it is 0, what does it mean? Our derivative is 0 means if h of x function h dash x is 0, what does it mean? Hx is?
H is a constant function.
Is constant. So if both, it will not change. That's the idea. So there is only one option where they are not changing. Understood?
Yes, sir.
So now you solve. Okay. Let's do an LMVT question. I have a couple of very interesting questions. So LMVT 1, question number 8. It says that fx is differentiable function between 0 and 5. Then gx is equal to fx by x plus 1. Prove that there exists a c between 0 and 5 such that gc is equal to minus 5 by 6. At first glance at the question, g dash of c is minus 5 by 6. What do you understand from the first glance at the question? What should you use?
Differentiate gx.
I don't think so you require to differentiate it. You can directly use mean value theorem here. It's told you have to show that there exists a c between 0 and 5. So your function, your definition here is also between 0 to 5 to r. Right? This is your definition. So this is your definition 0 to 5. So if you just use mean value theorem, f dash of c as, or g dash of c, g of 5 minus g of 0 by 5, right, is equal to f of 5 by 5 plus 1 minus f of 0 by 0 plus 1 by 5, right? Which is f of 5 is given to you, that is minus 1 by 6. F of 0 is given to you, that is 4 by 5. I don't know if I made some mistake here, so let's see. It's minus, right? Yeah. So this turns out to be minus 1 by 6 minus 25 divided by 5, which is minus 25 by 6 into 5, which is equal to minus 5 by 6. Agreed? So there exists a c, therefore there exists a c such that g dash of c is equal to minus 5 by 6. C is between 0 and 5. As soon as you see this, you have to understand it's a mean value theorem function. Between 0 and 5 is there. Question is, it's a straightforward mean value theorem question. Understood? How did I solve this? If you do not understand a step, you just ask.
So what does that symbol mean besides C in the last statement? Yes.
There exists.
Okay.
Inverted E means there exists. Did you understand the problem? How did I solve it?
Yes, sir.
I use mean value theorem to put 5 and 0 to the to G, and G's definition I used 5 by 6 and so on. G is defined as f of x by x plus 1, right? And your f of 5 and f of 4 and f of 5 is given to you, so it is proved, right? Understood?
Yes, sir.
Okay, so let's do number 9. Number 9 says that f dash of x is greater than 0 for all x. What does it mean? If this is given instantly, what should you understand?
Monotonically increasing function.
Monotonically increasing function.
Yes, sir.
Write it down. So f of x2 is greater than f of x1 for all x2 greater than x1, right? Agreed?
Yes, sir.
Good. So next, what will I do? Next, Tell me. So you have told g of x is f of 2 minus x plus f of 4 plus x, and you are told to show that g of x is increasing between minus 1 and infinity. How will I do that? Another implementation of applications, another application of derivatives. How will I do? Increasing function, how to show? How to show a function is increasing?
Differentiate it.
And it should be greater than 0. So g dash x is equal to f dash 2 minus x minus, right? By
Yes.
chain rule, I am differentiating fx and then differentiating ddx of 2 minus x, which is equal to minus 1. Similarly, 4 plus x into 1, and this is 0. Sorry, greater than 0, right? I want increasing function.
Yes, sir.
So I want your f dash of 4 plus x to be greater than f dash of 2 minus x, right?
Yes.
When will it be greater? If f dash x is 0, if it is if the function is an increasing function, so when will this be greater? For what values of is the derivative greater? So g of g dash of x is this. It's a monotonically increasing function, right?
Yes.
So my question is, your derivative has to, your 4 plus x must be greater than 2 minus this 4 plus x is greater than f dash of 2 minus x. So how will I say which, at what values will it be greater? Simply by doing this, right? So 4 plus, since it's an increasing function, 4 plus x will have to be greater than 2 minus x.
Yes.
It's an increasing function. So now my question is, there's a question I still have to ask, but anyways, let's do this first. 2x is minus 2, so x is greater than minus 1, right? So x belongs to minus 1 to infinity. This is the solution space. Now my question is, g of x has to be, is it told, show that, I think it is g prime of x, or is it g of x is increasing, it is said. So g dash x should be greater than 0. So f dash of x plus 4, okay, correct. So now tell me your derivatives, right? So since this function is an increasing function, whatever derivative you have, so if this value is greater than this on the right hand side, so your, just one second, which means that your f of x at these values. So for example, I need to say that if a function is increasing, if your f dash x is greater than 0, if your, now there is something, I think it should be f double dash of x is greater than 0. I think the question, okay, yeah, if double dash of x is greater than 0, I think this is the question, I forgot to put a double dash. So if f double dash x is greater than 0, your first derivative is monotonically increasing, right? That's why I forgot. Yeah, now I remember. So your f double dash of x is greater than 0 means f dash x is monotonically increasing, right? Agreed?
Yes.
So if f dash x is monotonically increasing, which means that f of f dash of x2 will be greater than f dash of x1 for all x2 greater than x1, right? Right, I need a second derivative here. There's nothing, no way other than that. So when I did this question, made this question, I did not realize that. So Now what did I do? I took the derivative of g of x because I want to see at what points g of x is maximum, right? Agreed? Increasing, right? I want to see g of x is as an increasing function. So I took the derivative and I said that f dash of x plus 4 is greater than f dash of 2 minus x, right? So at what point, so x plus 4 is something like this, and 2 minus x is something like this. So at what points are f of x dash are all these points, right? Minus 1, all points greater than minus 1, this above line is greater than the lower line, right? See, I took the derivative and took the thing to the other side. Now if this has to hold true, your 4 plus x has to be greater than 2 minus x, right?
Yes.
Because it's an increasing function, I have already defined it here. So that's what I did. So now I just solved it and got x greater than minus 1.
Yes.
So this is the proof. Any question?
No, sir.
Mr. Pandey, any question?
No, sir. Understood.
Okay. Number 10, right? Number 10. So here, for what values of b fx has the greatest value of at x is equal to 1? Let's see. So let's copy this question. We don't have enough space here. How do you think I should solve this question? What should be the solution? See, so what values of b, it has to be greatest value at this. So let's see. So f dash x first we'll have to see, right? Whether we can solve it using the derivative method. Can you use that to solve it using the derivative method? Let's see. So f dash x is 3x squared minus x 2x plus 10, right? For x less than minus 1 or 1, and minus 2 for x greater than 1. Agreed?
Yes.
So f dash of 1 is 3 minus 2 plus 10. Not seeing at f dash 1, the left hand derivative is minus as 11, the right hand derivative is 2, minus 2, right? So f x is not differentiable at x is equal to 1. Agreed?
Sir.
Go ahead.
So what? Why didn't we differentiate log base 2b square minus 2?
What is b? B is a constant.
Yes.
So b constant derivative will be?
Okay. 0 only.
So this is a constant only. Plus 0. So left hand derivative is not equal to right hand derivative. Agreed? So you cannot use the derivative method. So what can you use? So let's put f of 1. Or let's solve this. So f dash x for x less than 1. So is it an increasing function or a decreasing function? I claim that it is always greater than 0. Can you tell me why? Claim. You agree it is a concave upward function, right? Because a is positive. Any quadratics pointing upwards is positive, right?
Yes, upward parabola.
Upward parabola. Now I am telling you it's greater than 0. So how do I tell you it's greater than 0? By no root.
Vertical shift by 10 units.
No roots. If it does not have any root, it is always greater than x-axis, right?
Yes, sir.
So if it d is less than 0, or discriminant b square minus 4ac is less than 0, so you will have, see, you see it, 4 b square is 2 square minus 4 into 10 into 3, right? It is, which is less than 0, agreed? Minus 116 this is. So if it is negative, which means that there is no roots, we know x is defined as minus b plus minus root over of b square minus 4ac by 2a. This has to be greater than 0 for roots to exist, real roots to exist. If there are no real roots, it does not cut the x-axis, agreed?
Yes, sir.
Tanushri, agreed?
Oh, so can you explain it once again from d less than 0?
So if I'm asking if it is agree, if you understood or not, you should ask, right? So I shouldn't go about asking everyone. Today you have only 2 people. That's why I'm able to ask. So if d is greater than 0, by the definition, Sridhar Acharya formula, you have 2 roots, right?
Yes.
Upward facing, you understood, right?
Yes.
If it is upward facing by intermediate value theorem, you can, if you have 2 roots, you will either have 2 roots, a repeated root, or no root, right? If this is 0, you have repeated root, that is minus b by 2a. If it is not equal to 0, if it is greater than 0, you will have a root, right? 2 roots, decrease and then increase. Similarly, if it is d is less than 0, what does it mean? You have no roots, right? The root over of a negative number is any number. The roots are imaginary, right? Root b square minus 4ac, if it is less than root negative k, what is root over of minus 25? Minus 5i, right? 5i.
Yes, sir.
So 5i is an imaginary root, it's not a real root.
Yes.
So if there are no real root, it will not cut the x-axis, right?
Okay. Yes, sir.
So if it does not cut the x-axis, this is always greater than 0.
Yes.
So if it is greater than 0, fx is increasing, right?
Yes.
Fx is increasing for x less than 1. So for x less than 1, you have this as an increasing function. And up to where does it increase? It increases to 5. Why? So you just put value of f of 1, I think it is 5 or no. Yes, it is 6, I think, or 5, yes. So f of 1 is 1 minus 1 plus 10 minus 5, which is 5, right? Right?
Yes, sir.
So it increases up to 5. So I want, so it's something like this, some graph. I want to make it something like this, right? This is 2x plus some constant c. I want to change the constant to make it above. So in other words, log base 2 b square minus 2 should be greater than 5, correct? Agreed? This right hand side must be greater, right? So at x is equal to 1, you want to have fx as the greatest value. Or should it be lesser? F of x at 1 should be greatest value. It means it should be less than or equal to 5, right? I am a bit wrong here. Less than or equal to 5, not greater than. So because f of 1 is defined that way, otherwise I could have defined. So f of 1 is 5, right?
Yes.
So in the neighborhood, the value of the f5 should be greater than the neighborhood, right? 5 must be greater than the neighborhood. On the left hand neighborhood, it is always greater. We have seen by using the discriminant. Left hand neighborhood is true. right? Right
Yes.
hand neighborhood to be true, it must be below the curve, right? Less than 5 or 2x. This should be less than 5, right? I think this is what your confusion was, right? X is equal to at 1, right?
Yes.
So I put minus 2 plus log base 2 b square minus 2 is less than 5, or log b square minus 2 is less than 7, or b square base 2, right? B square minus 2 is 2 to the power 7, or b is less than root 30, 130. Agreed? So b has to be between, somewhere between. So this is the upper bound of b, and what should be the lower bound? What should be the lower bound? Log has to always have x is greater than 0, right? B square minus 2 has to be greater than 0. So b has to be greater than root 2. Okay? And union minus root 130 to minus root 2, because it's a square, it's a quad, like if I take a quadratic here, so what will I have? Let me just write it down again. So what is the solution? I think you are confused, but anyways, so b square is less than 130, right? So b can be between minus 130 to plus 130. So any number in between these two will be valid. We did not, because I'm taking square root, right? Square root minus of a square root is also same as square of is, or same as the positive of a square, right?
Yes, sir.
So b square, basically we are just projecting on both sides, right? So if this is one side is valid, both other side is also valid, since it's a square function, and b square has to be greater than 2. In other words, b square has to be less than minus 2, b has to be less than minus 2, and b has to be greater than 2. What is the intersection of this set? B belongs to minus 130 to minus 2 union root 2 to 130. Agreed?
Yes, sir.
To make it below, so Mr. Pandit, do you understand?
Yes, sir.
If you have a doubt, you ask. You didn't answer this.
No, sir. Very brilliant.
So what we did is we just put this line below the previous function, that's all, and solved for the value. This is the concept, rest is algebra. So the last question, were you able to solve this? I don't know why was this given in your question. You did not solve integration, but I was thinking let us just introduce the basics of integration today for polynomial function. This was in your assignment, right? If it is not in your assignment, then we can do it next day. This question was in your assignment, right? Question 12, I think this one is. We are doing 12th question or 11. So this was in your assignment, or it was not in your assignment?
Oh, sir, 1 second, let me check.
And were you able to solve it? Did you use integration to solve it? So anyways, dy dx is defined for if y is x to the power n, dy dx is defined as n x to the power n minus 1, right? So if I am given n x to the power n minus 1, what should be y? If dy dx is given to be this, so your y should be x to the power n, right? So I will not introduce integration today, but I will do it in a different way, right? So similarly, if dy dx is equal to x to the power n, y should be x to the power n plus 1 by n plus 1. Just take the derivative of this. Dy dx is n plus 1 into x to the power n plus 1 minus 1 by n plus 1, which is x to the power n, right? Why is everyone quiet? Was it not there?
Sir, clear power formula of integration.
It is clear, Tanushri?
Yes, sir.
So if dy dx is x to the power n, your y has to be plus some constant, because derivative of the constant is 0, right?
Yes.
So it is x to the power n plus 1 by n plus 1. You agreed? Just take
Yes,
an
sir.
inverse differentiation. We will not name it as an integral today. Inverse differentiation. We are just doing back calculation. Okay. So from second derivative to come to the first derivative, let us do it. So 15 x to the power half, right? And this is x to the power minus half. So what will it be? X to the power 3 by 2 by 3 by 2. Agreed? Plus 3 x to the power half by half plus some constant c. If you have problem with the calculation, tell me. Which is equal to 10 x to the power 3 by 2 plus 6 x to the power half plus c, right? Correct?
Yes, sir.
Okay. I put x is equal to 1, right? That's what is given, constant. I need to find the constant, right? I need to find the value of the constant. I put 1. I get 10 plus 6 plus c is equal to 8, right? Which means c is equal to minus 8. Agreed?
Yes, sir.
So y prime x is 10 x to the power 3 by 2 plus 6 x to the power half minus 8, right? Next is y. So what is y? Tell me fast.
10 x to the power 5 by 2
Yes.
by 5 by 2.
Next Tanushri will tell me. Next turn.
6x raised to 3 by 2 by 3 by 2.
And 8 will be 8x, right?
Yes.
Plus some constant c2. Again this is cut. So 4x to the power 5 by 2 plus 4x to the power 3 by 2 minus 8x plus c2 is equal to. So now we have also been given another term, that is f of 1 is equal to 0. I'll put 1 again. 1, x is equal to 1. So you will get 4 plus 4 minus 8 plus c2 is equal to 0. What is value of c2 then? 0, right? So y is 4x to the power 5 by 2 plus 4x to the power 3 by 2 minus 8x. You are told to find value at x is equal to 4. Let's see what it is. 4. So you have a root 4 to the power 5 plus 4 into root 4 to the power 3 minus 8 into 4. So you have 32, 4 into 32 plus 4 into 8 minus 4 into 8. This is 2 to the power 7. 2 to the power 4, 2 to the power 5 into 2 to the power 2. Right?
Yes, sir.
This was your, I think it was in your assignment, but you did not. You were able to solve this, means you know integration. Good. So that was for today. We have overshooted by 10 minutes. So what doubt do you have?
Sir, graph x to power 2 by 3 plus x minus 1 to power 2 by 3.
Do you really need to plot this? So
Yes, sir. Page number 320.
so what is x to the power?
2 by 3 plus x minus 1 का power 2 by 3. ये साइड में x minus 1 ब्रैकेट में.
Oh, 2 by 3.
2 by 3.
So first of all, tell me what is the graph. What will you use? So we can take it next day also. Today also I can do, but it will take some time. So what is the thing is this curve at infinity, x is equal to infinity. First, what I said, check at x is equal to infinity, right? At x is equal to infinity. This is infinity, right? Right? Similarly, f of x
Yes, sir.
at, so some points you check, then it will understand. X is equal to minus infinity. F of x is still infinity because it is power
Infinity.
is square. You have even power.
Positive power 2. Even power.
Good. So all values are greater than 0. So f of x is greater than 0 always. Right?
Yes, sir.
Next. F of 0 is 1. Right?
Yes, sir.
Good. Now we'll have to see increasing decreasing function thing. F dash
Yes, sir.
x.
That was the. Yes, sir. That is complicated a bit.
I don't think it is complicated. Minus 1 by 3
Plus.
plus x minus 1 to the power minus 1 by 3. That's all you need
2
to
by
see. 2 by 3. You have to see where it is greater than 0. So x to the power 1 by 3 plus x minus 1 to the power minus 1 by 3 is greater than 0. Where it is greater than 0? Is there any point where it is equal to 0?
Sir, minus 1 by 3 होगा sir. Minus 1 by 3.
So if I take square, so cube greater than 0, so cube will be 1 by x minus 1 would be greater than x, right? If I take cube,
1 by x, sir. 1 by x.
1 by x minus 1. This I took this side on the right.
Okay, sir. Okay.
And did a cube, right?
Here will be x to power minus 1 by 2.
1 by 2. Why?
1 by 3. X to power minus 1 by 3.
That's why I cubed both sides. X to the power 1 by 3 greater than 1 by x to the power 1 by 3, right? I cubed both sides.
No, sir. Here by 3. This will be. Just you have written x to power minus 1 by 3. Please see the question.
This one.
2 by 3,
Oh, this
x to
one.
power-
This one. Okay, okay. So 1 by
Yes, sir.
That's what you are saying. Oh, that is okay. I think
Yes.
that's a typo error. This is very simple,
Yes, sir.
right? So x greater than this, which means x is less than or minus x is less than x minus 1, right?
Yes, sir.
So or 2x is greater than 1.
Minus. Yes, sir.
X is greater than half.
Yes, sir.
So yeah, done. At half, at this is 1. At half you have after half you have increasing, before half you have
Yes,
decreasing. This is the graph.
There will be two more critical points. X is equal to 0, x is equal to 1.
0. 0 is not a critical point. 0
Sir,
is
sir, where f dash
Ah.
x is undefined, that is also a critical point.
F dash x is, yeah, if okay, correct, right. F dash x is 0.
Undefined.
F dash 0 is not defined.
Undefined. Not defined.
Not
That is
defined.
also a critical point.
And f dash 1 is also not defined. But f of x is defined at these 2 points. It doesn't matter. Right?
Okay, sir.
F of x 1
Yes.
is, there can be some, I'll see the curve once and see if it is not right or wrong. Then we'll have to see second derivatives. Otherwise, it's not required. Let's see.
Okay, sir.
It's at 1 also. So you're saying the curve.
Critical points.
No, critical points I understand. I only told critical points you have to see. So its curve is x to the power
2 by 3.
2 by 3
plus in bracket x minus 1 per power 2 by 3. Power 2 by 3.
So you're, I think between 0 and 1 also you will have an increasing point. That's why this is coming. I think cubing is, this is the curve. So we have almost got it right without taking the second derivative, but anyways, let me see. So at half you are saying you are having a critical point, right?
Yes, sir.
So let's draw this. So you have 0.
And x is equal to 0 also critical point, x is equal to 1 also critical point.
At 0 it is 1, right?
Yes, sir.
Oh, this is simple.
It is that.
I didn't see. So this is very simple. F of 0, right? It is symmetry after f of half. I can use the Rolle's theorem, right? So this is Rolle's theorem you can use. F of 1. F of 1
Okay.
is also 1, right? F of 0
Okay, sir.
is also
Is
1.
also 1.
And f of half is a maxima point.
Local maxima.
I'll do it more formally, but anyways, wait. You can take that d2 by dx2 and see if it will be less than 0 at half.
Yes, sir.
All this is all you need to do. Now the last thing is, why didn't we get it for between 1 and minus 1? This is my question. What did we make a mistake at that we did not get? So x greater than half, right?
Yes, sir.
In this case, x greater than half, we saw that it was, I think we made a mistake here. Oh, x greater than half cannot be used here, right? So cubing would invert the sign if x is less than 1. That is the,
Yes, sir. It will inverse it.
since it is a negative value, right?
Negative. Yes, sir.
Negative value will, cubing will, so this is the minus of 1 by 3. This is 1 by 3. So if x is greater than 1, this will hold true.
Yes, sir.
If it is, these things you have to be a bit careful. X is less than 1, your d2 by dx2 will be negative. dy dx is less than 0 between half and 1, right?
Okay, sir.
Correct. So 1 and 0 is not critical. It's a critical point because the derivative is not defined here. See, you have an edge.
Yes, sir. Corners.
You got the idea how to do it? Take the derivative.
Yes, sir.
Sometimes if derivative does not work, take the next second derivative and so on. And,
Okay, sir.
and sometimes be a bit careful with the calculation. For x less than 1, you will have a less than value. So that's why it is true. So these two intersection will give me x greater than 1, you will get this.
Okay, sir.
And similarly for x less than -1, dy dx is less than 0. And between my half and 1, you have 1, like greater than 0. Okay?
Okay, sir. Thank you, sir.
Yeah, I hope it helped.
Yes, sir.
Thank you. We'll see you next week.
Thank you, sir.
Bye, sir.
Bye.